Good morning, students. Today I am starting the second chapter, that is inverse trigonometric function. See, the topic is inverse trigonometric function. It is the second chapter in our second year PUC syllabus. Now, in the first chapter, relations and functions, you have studied about the inverse of a function. Okay, that is, we know that inverse of a function exists if and only if the function is a bijective. Bijective means it has to be 1, 1 and onto. Now, in this chapter, I am considering the inverse of a trigonometric function in particular. Now, let me consider a trigonometric function, that is the sine function. That is the sine function. And what is the domain of the sine function? The domain of the sine function is a set of the real numbers. And what is the range of this one? It is the closed interval minus 1 comma plus 1. So, the domain of the sine function is the set of the real numbers, and also the range is minus 1 comma 1, or you can write it as sine. This is the notation we use to denote a function here. Sine function is from the set of the real numbers to the closed interval minus 1 comma plus 1. Now, here suppose I take the whole of the domain, that is a set of real numbers. Let me the function cannot be considered as a 1, 1 function. For example, let me take a value sin x is equal to 1 by 2. Now, what can be the values of x here? X can be lying in the first quadrant, that is pi by 6, or it can lie in the second quadrant, pi minus pi by 6, because in the second quadrant also the sign is positive, or it can, after completing one round you can write it as 2 pi plus pi by 6, or you can write 3 pi minus pi by 6, etc. So, how many values we can write? We can write infinite number of values for x. All of them would certainly satisfy the equation sin x equal to 1 by 2. So, if you take all these values, then see, these are the values in the domain, and this becomes a value or the image. I can say the image of all of them would be 1 by 2. So, in that case, no function cannot be a 1, 1 function. So, automatically we cannot think about the inverse of a function. Suppose I restrict the domain instead of taking the whole of the set of the real numbers. Suppose I restrict the domain to the closed interval minus pi by 2 and pi by 2. Suppose instead of taking the whole domain, the set of the real numbers, if the domain is restricted to minus pi by 2 comma plus pi by 2, then in this interval the function sine function becomes both 1, 1 and onto, because for each value in this one we will be having a corresponding value, and it becomes onto for each value in the range we will be having a corresponding value in the domain. That's a pre-image will be there. For each number here there is an image, for each quantity there will be a pre-image. In other words, the function becomes both 1, 1 and onto, or in other words we call it as a bijective function. So, if instead of taking the whole domain, if you restrict it to minus pi by 2 comma plus pi by 2, then the function it becomes 1, 1 and onto. So, in this interval we can define the inverse of the function. Not only in this interval, it can be like this also, pi by 2 comma 3 pi by 2, or it can be taken as minus 3 pi by 2 comma minus pi by 2, all these intervals. Like this we can go on writing the other intervals also. In all these restricted intervals, the function becomes 1, 1 and onto. So, we can take any one of them, but this particular branch is called as the principal value branch. So, here instead of taking the whole domain of set of real numbers, if you restrict the domain to minus pi by 2 comma plus pi by 2, which is called as the principal value branch of the domain, the function becomes 1, 1 and onto. So, then and only then we can think of defining the inverse of the sine function. So, in that case now we define the sine inverse. and the notation is like this. It is not the index minus 1, this is the notation for the inverse function. So sine inverse, or it is also called as arc sine function. It is also called as arc sine function. So sine inverse function is the inverse of sine. And let me say what is the domain and what is the range of the function. That is, sine inverse can be considered as a function whose domain becomes minus 1 comma 1 and the range becomes the principal value branch. Just now I mentioned about the principal value branch, that is, the value would be lying between minus 1 and plus 1, and the images would be minus pi by 2 to plus pi by 2. So this is how we define the inverse function, inverse sine function. Now this is the notation we use. As usual, as we define the function, the same way we define the inverse function also. Here the domain becomes minus 1 comma from the closed interval, and the range becomes minus pi by 2 comma plus pi by 2. That is also a closed interval, because when we take only this particular branch, the function becomes both 1, 1 and on 2. Now this is the notation we use to denote the inverse of the sine function. Similarly, we can think about the cosine function also, that is the inverse of the cos function. Now let me consider the cos function. Again, here also the domain is the set of the real numbers and the range is the closed interval minus 1 comma 1. Now let me consider an interval, that is, here if you take the whole of the domain, that is a set of the real numbers, the cos function cannot be a 1 1 and onto function. Therefore, if you restrict the domain to a closed interval, for example, you take 0 to pi. 0 pi, both of them are included, it's a closed interval. In that case, now the function becomes both 1 1 and on 2. So 0 to pi by 2, positive value, pi by 2 to pi, negative value. So all of them would be included in this particular interval. Again, need not be the same thing. It can be the interval minus pi, 0, similarly pi and so we can consider different intervals here. In each of these interval, the function becomes the 1 1 and on 2. In other words, it is a bijective function. Again, for this one, this particular branch 0 to pi closed interval, we call it as a principal value branch. So if you take this interval, only then we can think about the inverse of the function. Again, the notation is cos inverse, and here we call it as the arc cosine function. It is called as the arc cosine function. Now how do you write this one? It is cos inverse, the domain is minus 1 1, and what is the range here? In this case, it is the closed interval 0 to pi here. So this is how we define the inverse of the cos function. Cos inverse is a function from the closed interval minus 1 to 1 to the closed interval 0 pi. Now let me consider the tan function. Now tan function, what is the range here? What is the domain? Again, for the tan function also, we consider the domain to be the set of the real numbers, isn't it? Set of the real numbers we consider. Now here this is how we write tan function is considered. Here you know that what can here this is the tan function x tan x. If you take tan x here, x takes the real value, that is it is we can write it as x such that x belongs to the set of the real numbers, but some values are omitted. What are they? X is not equal to 2n plus 1 into pi by 2. What is n here? N is an integer. Now omitting these values, now we can take the domain of the tan function here, because we know that any odd multiple of pi by 2, the function is not defined. We get 0, then we call it that the function is not defined. Though we write it as infinity, it is only a notation, the function is not defined. So omitting those values, the odd multiples of pi by 2, the function is defined here. Okay. So here if you take the all the interval, let me take the open interval pi minus pi by 2 plus pi by 2, because we cannot take the closed interval in this case. Closed interval means these two values will be included where the function is not defined. Therefore, we can take the open interval minus pi by 2 comma pi by 2, or you can take pi by 2 and 3 pi by 2 similarly, and the other one minus 3 pi by 2 minus pi by 2, like this. We have to take only the open intervals here, because for when you take the closed interval, the end values, no, at those points, no, the function is not defined at all. Therefore, when you take all these open intervals, the function tan becomes 1 1 and on to. Hence, we can define the inverse of a function. Okay. Now, again in this one, this particular interval minus pi by 2, the open interval, is considered as the principal value branch of that one. In that case, no, we can define the function tan inverse. Tan inverse is, how do you write this one? Tan inverse function, we have to omit all these intervals. We take only the principal value branch, and tan inverse, the domain becomes the set of real numbers, and this becomes the, it is minus pi by 2 and plus pi by 2, the open interval. This is how we define the tan inverse function. That is, the domain of the tan inverse function is the set of the real numbers, and the range becomes the open interval minus pi by 2 and plus pi by 2. Now, similarly, we can define the remaining 3 inverse trigonometric functions, that is secant inverse, cosecant inverse, and also the cot inverse. Now, in your question paper, usually in part A, 1 mark question will be asked, either just to write the domain or the range of any one of the inverse trigonometric functions. So, all these one, either you have to write the domain here, directly you can write the answer. If they ask you to write the domain of the secant inverse or the range of the secant inverse or cosecant inverse, like that, any one of them is usually given in part A for a 1 mark question. Now, here one thing you have to remember, we write, this is the notation, sine inverse x we write. It is not this minus 1, it looks like minus 1, but it is not an index. So, it is not equal to sine x to the power minus 1. This is a notation for the inverse function we are writing. So, don't mistake like this, it is not sin x to the power minus 1. Okay. So, the notation for inverse function, any inverse function, you have already learnt in first chapter, that is we write it as f inverse there. The same way here, we are considering a particular function. So, we use that word and write like minus 1 here, we read it as the inverse trigonometric function. That is, if sine inverse x is equal to y, then we write x to be equal to sine y. That is, if sine y is equal to x, then y can be written as sine inverse x. Or if sine inverse x is equal to y, x would be equal to sine inverse y. So, here y here, when you write like this, sine inverse x, x is a real number and y would be an angle. So, whenever we discuss about an inverse trigonometric function, this always gives us an angle. Now, let us see what are the respective domain and the range of the inverse trigonometric function. Now, let me write the function here. Let me take the function and then the domain and then the range here. Better you remember this information. It's usually given in 1 mark question in part A. Okay. Now, first function is sine inverse. Just now I told you what is the domain of this one. It is the closed interval minus 1 comma 1. Now, what is the range of this one? The range is the closed interval minus pi by 2 and plus pi by 2. Next, second one is cos inverse. Cos inverse, here also the domain is the same thing. That is the closed interval minus 1 comma 1. And what is the range in this case? It is again the closed interval 0 to pi, because all of them are principal value branches. And then tan inverse. Tan inverse. What is the domain here and what is the range here? Domain, as you know, is the set of the real numbers, and the range is the open interval pi by 2, minus pi by 2 and plus pi by 2. Next, let us come to cosecant inverse. And cosecant inverse, What can be the domain here? See, the domain is set of real numbers minus the open interval minus 1 comma 1. This becomes the domain of this one. And what is the range of that one? It is minus pi by 2, the closed interval, minus pi by 2 plus pi by 2. But 0 comes in between. But you know that sine cosecant is the inverse of cosecant is the reciprocal of sine. So here sine 0 means it is 0. Cosecant 0 becomes 1 by 0, which is not defined. So what we do here, we just take out that number 0 in this interval. So it is minus pi by 2 comma plus pi by 2 minus that set, okay, containing, it's a singleton containing the element 0. Similarly, secant inverse, it is, the domain is the same here. It is the set of real numbers minus the open interval minus 1 comma 1. And what is the domain here? What is the range here? The range is 0 to pi. And again here one element is omitted because you know that secant is the reciprocal of cos, and the cos 0 means cos pi by 2 means it is 0. Secant pi by 2 becomes 1 by 0, which is not defined. Now lastly, the cot inverse. Cot inverse is a function. What can be the domain of this one? The domain is the set of the real numbers. And what can be the range of this one? Here we are considering this 0 to pi, it is an open interval. So these are the respective domain and the range of these functions. So this is an important information. Students should remember this one. Again I am repeating, any one question can be asked for a 1 mark question in part A. Now the next thing is, for 1 mark question this is one possibility, and another thing. Now we define another word, principal value. What do you mean by principal value? Now, the principal value of an inverse trigonometric function. The principal value. Now, the value of the inverse trigonometric function which lies in the range of the principal value branch is called as the principal value. So here, see, because these trigonometric functions are periodic functions, the values get repeated. So here I am repeating, value of an inverse trigonometric function is the value which lies in the range of the principal value branch of the function, of the function. Now, for example, let me consider sine inverse of, say, 1 by root of 2. Now it is again 1 mark question is expected from this particular topic, either to write the range or the domain of an inverse trigonometric function. The other possibility is you can be asked to give the principal value of an inverse trigonometric function for a 1 mark question. Now let us see how to find this one. I am telling you the calculation part of that one, but for a 1 mark question so much of calculation is not necessary. Whenever a standard value is given, directly you can write the answer. But let me show you how the calculation takes place. I told you always inverse trigonometric function denotes an angle. Let me denote this to be equal to theta. Our problem is to find the value of theta here. Now sine inverse 1 by root of 2 is equal to theta, means using this definition I can write sine theta to be equal to 1 by root of 2. Now 1 by root of 2, and also what is the principal value branch? Principal value branch is minus pi by 2. The range of the principal value branch is minus pi by 2 plus pi by 2. So which value which will suit this one and which lies in that interval is, you know that sine of pi by 4 is also equal to 1 by root of 2, and you observe that pi by 4 lies in this closed interval. Therefore, sine pi by 4 equal to 1 by root of 2 means here I can write it as sine theta is equal to sine pi by 4. Therefore, theta is equal to pi by 4. But what is theta? Earlier we had assumed it to be sine inverse of 1 by root of 2 will be equal to pi by 4. Now this is the principal value of the given inverse trigonometric function. Okay. Now you can see that it is a standard value, and you know that sine 45 degrees or sine pi by 4 is equal to 1 by root of 2. So directly you can write the answer. You can give the reason. Sine inverse 1 by root of 2 is equal to pi by 4. You can give the reason since sine pi by 4 is equal to 1 by root of 2. You need not give the reason that it lies in the principal value. Those sentences are not necessary. Writing the answer directly, giving the reason for that one would be enough for a 1 mark question. Now, let me consider another example. Cos inverse of 1 by 2. Now, let me equate it to some angle, say A. That is, I can write it as cos A would be equal to 1 by 2. What is the principal value branch of this one? It is the closed interval 0, pi, isn't it? Now, we know that cos of pi by 3, which lies in this interval, is also equal to 1 by 2. Therefore, I can write A would be equal to pi by 3. But what is A here? A means it is cos inverse of half is equal to pi by 3. Therefore, the principal value of this inverse trigonometry function cos inverse half is equal to pi by 3. So, this is the principal value. It should lie in the principal value branch of that one. Now, let me take another example. Tan inverse of root of 3. Tan inverse of root of 3. Now, let me equate it to another angle, say B. Now, here that means that tan of B would be equal to root of 3. But what is the principal value branch here? The principal value branch would be the open interval minus pi by 2 comma plus pi by 2. And we know that tan of 60, or in other words pi by 3 is equal to root of 3, and pi by 3 lies in this open interval minus pi by 2 and plus pi by 2, which implies that tan inverse of root 3 can be written as pi by 3. So, these are the principal values of the respective inverse trigonometry functions. So, I told you these are the types of problems you can expect for a 1 mark question where we find the value of the principal value of the function. Now, let us, I told you this is how the calculation takes place, but we need not show all this one. So, let me work out some more problems where we find the principal values of the given functions. First, let me find the principal value. That's how the question would be. Sine inverse of 0. Now, 0 is a standard value, as you know. So, you can write it as sine inverse of 0 is equal to 0. Give the reason since sine of 0 would be equal to 0. Similarly, another problem, it is cos inverse of 0. That can be written as pi by 2. Remember, you have to look at the standard value, you have to remember the principal value branch, and in that one you have to write the value directly. The reason is since we know that cos pi by 2 is equal to 0. Now, consider another example, tan inverse of 1. What is tan inverse of 1 equal to? It is pi by 4, because we know that tan 45 degrees or tan pi by 4, which lies in that particular principal value branch, would be equal to 1. Therefore, give the reason since we know that tan pi by 4 would be equal to 1. Now, similarly, we take some other examples here. Let me consider cos inverse of 1. Cos inverse of 1. What can be cos inverse of 1? This is equal to 0, because we know that cos of 0 is equal to 1 here. Similarly, take another example, sine inverse 1. Sine inverse 1 is equal to pi by 2. Give the reason since sine of pi by 2 is equal to 1. So, always we have to have in our mind about the principal value branch of the particular inverse function. Next, you consider secant inverse of root of 2. Now, this would be equal to pi by 4. The reason is secant pi by 4 would be equal to root of 2. Now, consider another problem. Cosecant inverse of 2 by root of 3. This is equal to pi by 3 or 60 degrees, since cosecant pi by 3 would be equal to 2 by root of 3. Now take another example. Cot inverse of root of 3. Cot inverse of root of 3 is pi by 6, since cot of pi by 6 would be equal, or cot of 30 would be equal to root of 3. So these are the directly you can write when it is a standard value. Of course, you can observe that I am considering only the positive values here. All of them are positive numbers which are given inside the bracket. I will come to the negative numbers in the coming classes. So here all of them are standard values, all of them are positive values. So you know that in the first quadrant all the trigonometric ratios are positive. So all these angles are acute angles which are lying in the first quadrant. So when they ask you to find the principal value, always look at the number. If it's a standard value, you can directly write the value corresponding to that one, bearing in mind the principal value branch of the particular function. Okay. Now, under that, one more information I want to give you. Now, in the previous chapter, relations and functions, you have learnt about the composite functions. That is, two functions can be combined. Okay, if two functions f and g are there, they can be operated one after another. We write FOG or f operation g, or you write GOF. Similarly, here let me consider the two functions, compositions of two functions. One is the trigonometric function, the other is the inverse of the function. For example, first one, sine inverse of x. Here look at this one. See, both of them are mutually inverse functions. For sine inverse is the inverse. For sine inverse, sine is the inverse. They are mutually inverse, the mutual inverses of each other. I can say they are the inverses of each other, or the mutual inverses. Now, what can be the value? It would be exactly equal to x here. First we are operating the inverse function, then we are operating the trigonometric function. Automatically it will be equal to x. For example, there is a number 10, let us take. You add 4 to that one. You add 4 to that one. That means one operation has been done. Then you add minus 4 to that one. Now addition, subtraction, they are mutual inverses here. So when you add 4, subtract 4, what remains here? Again we get back the original number. In the same way here, we are doing two mutual inverse operations, so the number remains the same. But here the condition is that x should belong to the interval -1, 1. That is the that particular interval. So when it belongs to that particular interval, or you can write in the form of an inequalities also, or you can write in the form of an interval also. Similarly, cos inverse of x would be equal to x. Then same thing, same interval we can consider. X should belong to the open interval, the closed interval -1, 1, or you can write in the form of an inequality also. Next one, tan inverse of x. Again it would be equal to x. What is the condition? X should be a real number. Here the same thing, x should be a real number. Here what I have done? First I have operated the inverse function, then I have operated the sine function. These are the three, because when we work out the problems, we come across such situations, then directly you can write the values. Now let me consider in the other order. That is, let me consider sine inverse of sin x. Sine inverse of sin x. Here we are operating the trigonometric function. Then we are operating its own inverse function here. So the value would be, or you can take it as theta. Not to have any confusion, sine inverse of sin theta would be equal to theta. In this case, theta is an angle. What is the condition here? theta should belong to the interval, the closed interval, that is it should belong to the principal value branch, because you cannot take any other value. So it is minus pi by 2 plus pi by 2. It lies in the closed interval. Then only you can write. Suppose I am having here sine inverse of sine of 240 degrees. In that case, now don't write the value to be 240 degrees. You see, you have to use the allied angle rules and convert this into an angle which lies in that particular interval. Then only you can write the value, not otherwise. So, similarly, you take another one. Cos inverse of cos of theta. Here it is equal to theta. What's the condition here? It should, because we are considering the cosine function, it should belong to the interval 0, pi. So only if it lies in that particular interval. Suppose I give you cos inverse of cos of 300 degrees. Okay. You see that the angle comes to that one again using the allied angle. Then we can write the value directly to be equal to theta. And the last one, tan inverse of tan theta. Tan inverse of tan theta. Again you can take it as theta. What's the condition here? Theta should belong to the open interval. Theta should belong to the open interval minus, here all of them you observe they are nothing but the principal value branches. So the function, first we may operate the inverse function, then we may operate the direct function. Then you have to see that where exactly the value lies. And when you operate the trigonometric function, then its own inverse function, see that the angle lies in the respective the principal value branch. So this information you have to remember, because for a 2 mark question or 1 mark question we come across these problems again. Okay, in that case now many students, now whenever they have this angle which is not lying in that interval also, directly they write the value theta. Then you don't get any marks for that one. So you have to see that particular value, depending upon the function that has been given, you have to see that angle lies in that particular principal value branch. Then only the result is applicable. Now for this session, this much of information is about. In the next session, I am going to teach you about some important properties of inverse trigonometric function. Already told you about in the introduction that these properties are very important. So there are 5 sets of properties I am going to prove here, and then all of them, some are asked for a 1 mark question, some for 2 mark question, some for 3 mark question. They are regularly asked question in the question paper. Therefore, in the next session, I am going to teach you about the 5 sets of properties of inverse trigonometric function and also their proof. And you have to remember the proof also. You have to write and practice about the proof, because they are expected in the examination. Thank you.